let's do some conceptual problems for impulse and momentum. For these, you're going to want to read the questions very, very carefully. Which has greater mass? Okay, a heavy truck at rest or a rolling skateboard? Well, let's see. Here's my pictures. Here's my heavy truck. And we're not going to laugh at my trucks. Here's the headlights. Looks like whiskers. Here's a skateboard. Now, the truck has a mass mt. The skateboard has a mass m skateboard. The truck is at rest, so the velocity of the truck is 0. And the skateboard, I don't know, it has some velocity v. So, which one has a greater mass? Remember, mass is just a measure of inertia, which is the amount of stuff. So which one has more stuff? Clearly, that's the truck. Now, which one has greater momentum? Well, the momentum of the truck is the mass of the truck times the velocity of the truck. Since the velocity of the truck is 0, the momentum of the truck is 0. The skateboard has momentum equal to the mass of the skateboard times the velocity of the skateboard. So, as long as the velocity of the skateboard is not 0, the skateboard has more momentum than the truck. Distinguish between impact and impulse. Impact means you have hit something. Okay. Remember, we have told you that a force is a push or a pull. So something has been pushed or it has been pulled. That's basically what hitting means. While impulse is a measure of force applied, the impact, over a period of time. Which designates a force? Well, that's the impact. And which is force times time? That's the impulse. So you can think of impulse is an impact force times time, if that helps. Now, when the force of impact on an object is extended in time, does the impulse increase or decrease? Well, let's see. Impulse is force times time. So let's use some arrows here. If the force is extended in time, so if time goes up and the force stays the same, we see the impulse must increase. If the force, let's shove some numbers in here. Say the force is 2 newtons and it does not change. If the time increases from, say, 1 second to 2 seconds, we see the impact of the first time is going to be 2 newtons times 1 second, or 2 newton seconds, while the impulse the second time is the same force, 2 newtons times 2 seconds, or 4 newton seconds. Now, for a constant force, suppose that impact time is doubled. How much does the impulse increase, and how much is the resulting change in momentum? I kind of almost already answered this one. Impulse equals Ft. So if the force is constant, it's not changing. If I double the impact time, I see my new impulse is going to be twice my original impulse. Now remember, impulse equals change in momentum. So if my new impulse is doubled, then my new momentum will also be doubled. Now, in a car crash, why is it advantageous for an occupant to extend the time over which the collision occurs? Well, impulse equals change in momentum. Now, in a car crash, here's your car, and it has a collision with, say, a wall. It stops. So it has an initial velocity. In any collision, the change in momentum is going to be the mass times v final minus v initial. So since your final velocity is 0, your change in momentum is always going to be mvi, and that negative sign just tells you direction. So your impulse is going to be equal to your change in momentum, and the impulse is ft, and that's mvi minus mvi, because this is, you remember, change in momentum, so I'm going to plug that in. Now, let's solve this for force. The force is equal to mvi over t, and I'm just going to leave that negative sign in there. That just means opposite direction. Now, the force is what breaks your nose or hurts you really badly. You can see by increasing the time, this is going to decrease the force because these two are inversely related. So by increasing time, you decrease force. If you were to decrease the time, that would increase the force of impact, which is one thing that makes seat belts and airbags so advantageous.